To understand the atmospheric stability, some of the materials that we need to explore. Most cloud form as air rises and cools. Why does air rises on some occasions and not on other occasions? And we can say, why does the size and shape of the cloud vary so much when the air does rise? Let's see how knowingly about the air stability will help us to answer this question. So when we speak the atmospheric stability, we are referring to a condition of equilibrium. So to explore the behavior of rising and sinking air, we must first put some air in an imaginary thin elastic wrap. The small volume of air is referred to as a parcel of the air. Although the air parcel can expand and contract freely, it does not break apart but remain as a single unit. At the same time, neither external air nor heat can mix with the air inside the parcel. So the space occupied by the air molecule within the parcel define the air density. The average speed of the molecule is directly related to the air temperature, and the molecule actually collide against the parcel wall that determine the air pressure inside. So as Earth's surface, the parcel has some same temperature and the same pressure as the air surrounding. Suppose we lift air parcel up to the atmosphere. The air pressure surrounding the parcel lower and the lower pressure outside allow the air molecule inside, and it push the parcel wall outward, and this expanding the parcel. This happens because there is no other energy sources, and the air molecule inside must use some of their own energy to expand the parcel. So this shows up as slower average molecular speed when air cools. So this results in a lower parcel temperature. If the parcel is lower to the surface, it returns to the region where the surrounding air pressure is higher. The higher pressure squeezes or compresses the parcel back to its normal or original smaller volume. So this squeezing increases the average speed of the air molecule, and the parcel temperature rises. So we can say a rising parcel of air expands and cools. When air goes up, it expands and it cools. While we can say other thing, the sinking parcel is compressed and warm. Compress collide each other more rapidly, create heat, and that heat create warm temperature. So rising parcel expand and cool, temperature decreases, and sinking parcel compress and warm, temperature increases. So from here, the fundamental things we need to know. The part 1, when air is compressed, its temperature will increase. When air is expand, its temperature will decrease. So we'll be learning about the environmental lapse rate, adiabatic lapse rate, wet adiabatic lapse rate, dry adiabatic lapse rate, how all these are related to atmospheric stability in the next videos.